Alright guys, in this video we'll be looking at graphing hyperbolas, and there will be two different equations that we'll be working with, and depending on which equation we have will determine what type of hyperbola or the direction of opening that we have. So you'll notice the first one in red here, x minus h squared over a squared minus y minus k squared over b squared equals 1. Anytime we have this form of the equation, we'll be having a hyperbola that opens up left and right, as you see here. We've got this one that opens up left, and this section that opens up to the right. Now you'll notice the second equation in blue here. Notice how the negative or the minus sign is now in front of the x minus h squared over a squared, and then we have plus y minus k squared over b squared equals 1. And anytime we have this negative sign in front of our equation, rather than having the hyperbola opening up sideways left and right, the hyperbola will open up and down. This is opening up, this is opening down. So again, we're going to have to pay special attention to where that negative sign is, because that's going to help us determine what direction the hyperbola opens, whether it opens up left and right or whether it opens up and down. Alright, so let's go ahead and take a look at some examples here. Alright, here's our first example. We've got x minus 3 squared over 16 minus y plus 1 squared over 9 equals 1. And we want to graph this hyperbola. The first thing we're going to notice is where that negative or minus sign is. Notice it's right in the middle here. So what that tells me is that my hyperbola is going to open up left and right. So when I get done, I should have a hyperbola opening up sideways here. So let's keep that in mind. Now, in order to graph this, the first thing I'm going to need to find is the center of the hyperbola. And to find the center, we're going to use h and k. Same way we did with ellipses, same way we did with circles. We're going to do the same thing here with our hyperbolas, h and k. H is the opposite of this number here, and that's going to be a positive 3. K is the opposite of this number here, which would be a negative 1. So the center of our hyperbola is going to be at 3, negative 1. So what I'm going to do is come to my graph paper and find 3, negative 1, which is right here. And that's going to be the center. Next thing I'm going to need to find is my horizontal distance, or A. And to find A, all we're going to do is take the square root of this number here. And the square root of 16 would be 4. So what we're going to do is from the center, we're going to move 4 units to the right. 1, 2, 3, 4. And we're also going to move 4 units to the left. 1, 2, 3, 4. The next thing I'm going to find is my vertical distance, and to find that vertical distance we're going to take the square root of this number here. The square root of 9 would be 3. So again, from my center I'm going to move up 3 units, which would put me right here, and then I'm going to move down 3 units from the center, which would put me right here. So at this point I've got a center and I've got these 4 points. So what I'm going to do is I'm going to take these 4 points and use them as center points of the sides of a rectangle. So what I'm going to do is draw a rectangle. Notice that I'm using a dotted line to draw my rectangle, because it's not actually part of the graph, it's just helping me, or guidelines. So now what I've done is I've created a box. Notice how these 4 points are at the center of each of the sides. Now the purpose of this box is so that we can draw 2 lines called asymptotes. So what we're going to do is we're going to go from one corner of the box to the opposite corner diagonally. So we're going to have a line that goes through like this. Notice how it also goes through the center. We'll do another line going from one corner to the opposite corner. Once again, notice how it goes through the center. These 2 lines that I've drawn are called the asymptotes, and these are going to help us draw our hyperbola. Now keep in mind, we did say earlier that our graph is going to open up left and right. So what I'm going to do now is I'm going to go ahead and draw the sides of this hyperbola. Now keep in mind, we are going to have to make sure that our hyperbola goes through these points called the vertices. We're going to come up right against that asymptote there. We're going to touch that point called the vertex, and then we'll come around here and run up against that asymptote. Then we'll go ahead and do the same thing on the other side. We'll go ahead and run up against the asymptote, touch that point called the vertex, and then come across or up against that other asymptote. So this would be the graph of our hyperbola that has the equation x minus 3 squared over 16 minus y plus 1 squared over 9 equals 1. Alright, next example we have here is x minus 2 squared over 25 minus y squared equals 1. Alright, now again we're going to first look at the negative or the minus sign, find where that's at, which in this case is here in the center. And because it's in the center, when I graph this hyperbola, it should be opening up sideways, left and right. So this is what the graph should look like when I get done. So in order to get this graph, there's a couple of things I'm going to need to know. First thing I'm going to need to know is where the center is at. And the center is located at HK. So remember, H is the opposite of this number, which is positive 2. K, now notice there is no K over here, so we're going to use the value 0. So the center of this hyperbola is going to be located at 2, 0, which is going to be right here on top of our x-axis. That's the center of our hyperbola. Once we know the center of our hyperbola, the next thing we're going to do is find our horizontal distance, how much we're going to move left and right from that center. And to find that, we're going to look here. We're going to take the square root of 25. The square root of 25 is 5, which tells me from the center I need to move 5 units. So I'm going to go 1, 2, 3, 4, 5 to the right. And then I'll go 1, 2, 3, 4, 5 to the left. Now what I'm going to do is look for the vertical distance. Now usually we have a number underneath that y squared, and as you can see right now I don't. So what I'm going to do is I'm going to go ahead and put 1. And I can put the number 1 without actually changing the value of a y squared, because y squared divided by 1 is still equal to a y squared. So what I'm going to do now is, now that I know that number is 1, we're going to take the square root of 1, and the square root of 1 is 1, which tells me my vertical distance is 1. So from the center we're going to go up 1 unit, and we're also going to go down 1 unit. Alright, so now that I have these 4 points, we're going to use these 4 points to create our box. Remember, I'm using dotted lines to draw this box because it's not actually part of the graph. They're just kind of guidelines to help me graph. Once I have the box, we're going to run some lines from one corner to the opposite, going through the center. These are called asymptotes. So there's one asymptote. Then I'll do another one in the opposite direction here. So these lines again are called the asymptotes. These are guidelines. These are what's going to help me draw my hyperbola. Now remember, we said that the graph is going to open up sideways, left and right. So as I did on the first example, I'm going to come right up against the asymptote, touch the point called the vertex, and come back around up against that other asymptote. Do the same thing on the other side. Touch the vertex and run up right against that asymptote there. So this is the graph of the equation x minus 2 squared over 25 minus y squared equals 1. Now remember guys, these points right here are called vertices. These 2 points over here that you see here, these would be called co-vertices. Alright. Okay, next example, we've got the equation negative x minus 4 squared over 16 plus y plus 2 squared over 4 equals 1. Now I want you to notice this time where that negative sign is. Notice it's up here in the front here. And because it's up in the front, this time our hyperbola is going to open up and down. So the graph is going to end up looking something like this when I get done. It's going to open up and down rather than left and right, as we saw in the first 2 examples. Okay. Alright, so to get this graph, we're going to go through the same process as we did with the others. We're going to start by finding the center, h and k. H is just the opposite of this number here, which would be 4. K is the opposite of this number here, which would be negative 2. So the center of this hyperbola is going to be located at the ordered pair 4, negative 2, which would be right here. That's going to be our center. Now we need to find the horizontal distance, and to find that we're going to take the square root of 16, and the square root of 16 is 4. So we're going to move 1, 2, 3, 4 units to the right, 1, 2, 3, 4 units to the left. That's our horizontal distance. Now we're going to do our vertical distance. Vertical distance can be found by taking the square root of 4, and the square root of 4 is 2. So from the center we're going to go up 2, we're also going to go down 2. Now remember, the reason we have these 4 points is so that we can use these points to draw a box. So we're going to draw our dotted box. And remember, the reason it's dotted is because it's not actually part of the graph, it's just guidelines. And the reason we want this box is so that we can use it to draw our asymptotes. So we're going to go ahead and go from one corner to the opposite corner, making sure that it goes through the center. Do the same thing the other direction. Make sure it goes to the center. And now we have our 2 asymptotes. Now, just remember, this time we said our graph is going to open up and down. So when I draw this, I need to make sure that it opens up and down. It looks something like this here. So what I'm going to do is run up right against the asymptote. I'm going to come right over here and touch that point called the vertex, and then run up against that asymptote there. Do the same thing at the bottom. I'm going to run up against the asymptote, touch that point called the vertex, and then run up against that other asymptote. So now we have our graph of this equation here. Now remember, these points that we have here are called vertices. These other 2 points that we have over here are called the co-vertices. So the vertices will always be located on the hyperbola itself. The co-vertices are the other 2 points. So let's make sure we get that straight, because if you look at the other 2 examples, the co-vertices were the yellow dots and the vertices were the green dots. Now it's the opposite. Alright, so again, the vertices will always be on top of the hyperbola.